All right, so my name is Dennison Bertram. I'm developer advocate at Zeppelin. You know us, we build open source tools to help developers build secure applications. We also audit smart contracts. We do a lot of auditing services. And we recently have released a new product called ZeppKit, which is all-in-one tool to help you really jumpstart your dApp development. So I'm going to pass it over to Fran, who's going to start to tell you more.
Hi, guys. I was told to project my voice. I'm not sure how that's going to go. So I'm Fran. I'm one of the maintainers of Open Zeppelin. So today I'm going to tell you a little bit about what it is and how we think of it. Can you speak up a little bit? Yes. So I'm going to tell you about what it is, how we think about it at Zeppelin, and hopefully inspire you to use it in your projects at the hackathon and maybe contribute to it afterwards. So Open Zeppelin is a modular library of full-blown contracts and contract components that you can use to build up the smart contract side of your decentralized apps. So anything to do with either implementing or interacting with smart contracts, Open Zeppelin can help you with. An important aspect of the project is the focus that we put on security, which has been there since the inception of the project, actually. And in fact, the reason Open Zeppelin was born was that at the time, there was no one standard for good code quality in Solidity and good practices. So Open Zeppelin was born to sort of be that central place where we can see good code, use it as well, and see some good practices. What do I mean by security? So the way that we ensure security of the library is through thorough code review of every pull request that comes in. This can be sometimes annoying if you try to contribute, but it's how we keep up the quality of the project. Lots of tests, and in fact we reached 100% coverage recently. And also auditability and audit. So as we write the code, as we review pull requests, we focus on code being easily auditable. This has a lot to do with the modularity of it. And we do audits, both internal by the research and audits team at Zeppelin, and external, like we did back in November for version 2.0 with level K. So related to this also, we rely a bit on an informal review by the community. So Open Zeppelin is a popular project, and these are some numbers for that popularity. And this means that we get a constant stream of people coming to the repository, using the tools and looking at the code, and sending in pull requests for improvements. And I think this really helps to keep up the quality. Also related to security, this is more new that we're experimenting with. On the design side, we're trying to build simple APIs that are hard to misuse and to encapsulate state to completely disallow invalid or incorrect things. So onto what you can do with Open Zeppelin other than audit it. There it says ERCs. We have some implementations of ERCs. The typical one is ERC20. And what you'll find is that we have this IERC20 interface. This declares the standard interface defined in the document that ERC20 contracts have to adhere to. Then we have the implementation of this interface and the optional extension in this case. And we also have some extensions of things that we think are useful, in general, like minting ERC20 tokens on demand. And this is a pattern that you're going to see throughout Open Zeppelin, so you should pay attention to it. For example, the 721 ERC, which is non-fungible tokens, also has the same interfaces. In this case, there are many because there are some optional extensions. Then you have the implementations and more custom extensions that we wrote. What you need to know about this is that you can combine these things through multiple inheritance in Solidity. And in many cases, you're expected to do this. So in the case of ERC 721s, in this here I combined the core implementation with the metadata extension and the mintability extension. I need to drink some water. Thank you. And yeah, this is how you're expected to use Open Zeppelin. We also have ERC 165, for example, which defines a way to query if a contract answers to a certain interface, like ERC 721. And in this case, we also have the interface and the implementation, but also an utility in this case, which is the way that you can, like the other side of ERC 165, which is how you can query that something supports it. And this is a little bit tricky. It's not as easy as it should be, but so we implement it for you to use it. Other than these contracts, we also have some components that you can put in your own contracts for whatever you're doing. For example, poll payment. In the case that you want to send Ether to an address without executing the code that is in it, for example, to be more strict about your gas usage or for security concerns, you can use poll payment. And the way poll payment works is it gives you this internal function, which is an async transfer, which just puts this money, the Ether, like in a secure place where then anyone actually can go and trigger the actual Ether transfer, like this here. And this is an external call. You also have, for example, ECDSA, elliptic curve digital signatures, which is the native cryptographic algorithm in the EVM. The Solidity interface is a bit cumbersome, so we wrapped it up in this ECDSA contract to, sorry, you're covering the screen. Thank you. To make it simpler to use. And also, this is a blank slide to make me remember say this. I think Open Zeppelin is a mature project. It's complex, and we ran into many problems in the ecosystem. So we've had to solve, for example, setting up coverage, setting up a full-blown test suite, and like making that work. So I think it's a really good place where you can go look for inspiration for your own projects. Copy ideas, maybe copy some scripts that we have in there. I think that's useful. We have some new stuff. We have a new discourse forum where we want to discuss anything to do with Open Zeppelin and also help you solve any problems that you run into. And this isn't ready yet, but it's coming soon, and I'm very excited about it. We're improving the documentation. We do have a doc site right now, but it's not the best. We know that. And we're building some tools to build like really useful documentation specifically tailored for smart contracts. So be on the lookout for that. I think it's going to be great. So do you think we're missing an important ERC or feature? Come talk to me. I'll be happy to hear that. There are tons of ERCs, and it's really hard to keep track of them. So you voicing that you think it's important is important for us. And did you come up with something cool during the hackathon? Also, let us know. We're looking for new things to put in the library, and if you think you built something that fits in there, come tell me. We can talk about it. So now Santiago is going to tell you more about Zeppelin OS.
Thank you so much. Let me just here. Still working? Okay. Thank you. Okay. Can you guys hear me okay? Yes? Okay, awesome. Sorry for the audio issues. Okay, so first of all, what's Zeppelin OS? Basically, Fran has just told you about Open Zeppelin, which is a set of building blocks for building your own smart contracts. Zeppelin OS is a toolset for actually managing those smart contracts. It will allow you to deploy them, manage them, and also upgrade them. So how do we ship Zeppelin OS? Zeppelin OS is basically, its main interface is a CLI that we provide via NPM. It's a CCS running NPM install ZOS. So, and I wanted to mention also that Zeppelin OS basically runs on top of Truffle, Web3, Solidity compiler, your typical stack, and it adds a few more features, such as mainly upgradability. So, what's upgradability? The idea is that via Zeppelin OS, you can modify the code of your contracts after you have deployed them, while maintaining their state, their address, their balance. Basically, you can just keep all, but you can actually modify the code after they have been developed. This allows you to fix bugs after you have gone into production. It allows you to have an iterative development style where you don't need to nail it on the first run. You can just add new features as you go. And you can even use it to develop faster. You can use Zeppelin OS in your development environment and just add new features as you go without needing to recreate the state from scratch, because Zeppelin OS is going to take care of preserving that. So how does it work? Let's say we have that wallet contract. It's going to be a very simple one. It's just going to track whoever its owner, just an address. And here is the only difference that you need to take into account when developing in Zeppelin OS. When you write contracts, when you write upgradable contracts, you cannot use constructors in Solidity. You have to replace them by an initializer function, which is going to have exactly the same behavior. This is due to an implementation detail. We're working on automating this. But for now, just keep in mind that if you're writing upgradable contracts, you need to replace constructors by just an initialize function. Let's go into detail into that in a minute. So how is this going to work? Basically, using the CLI for Zeppelin OS, you just tell Zeppelin OS to start tracking your contract, similar to a Git add. Then you push your code onto a particular network, whether it's Rinkeby, mainnet, or even a local ganache. And then you can start creating new upgradable instances of your smart contracts. So you just run Zeppelin OS create, for instance, my wallet, which is the contract we just wrote. And we specify whichever arguments we want, such as the owner address or whatever it is. And Zeppelin OS is going to create an upgradable instance and tell us which address it's sitting. Okay, so far so good. Let's say we start interacting with this contract. We have added funds to it. We can query its owner for what it's worth, but we don't have a way to actually withdraw those contracts. So as you can see, it's actually a very simple example, but it helps to illustrate the thing. So we can then add a new function to our contract and just tell Zeppelin OS to upgrade that new instance. We just push the new code on chain and tell Zeppelin OS to update all instances of the wallet contract that we have just deployed. Something very important to mark here is that the address is going to be the same. Okay, so even though you have changed the code, the address that you're interacting with, or your client, or an exchange, or whatever it is always going to be the same address. The Ethereum balance is going to be the same. The owner of the contract is going to be the same. You just get new code up and running, okay? So you're preserving the same address for interacting with your contracts. You just have deployed new code over there. So how does this work? We are used to knowing that all smart contracts after deployed are immutable. Basically, we rely on a pattern, on a delegate proxy pattern. So what happens is that under the hood, Zeppelin OS is not deploying just your wallet contract. It's actually deploying two contracts. It's first going to deploy whatever code you have written. We call that the logic contract, and we just use it for the code. It doesn't hold any state at all. All the state and actually the address that your clients interact with is going to be the proxy contract. The proxy is very, very small contract that the only thing it does, it just delegates all calls to the logic contract. Delegate call is actually an opcode at the EVM level. It basically says, okay, execute the code on this contract in the context of this particular contract. And by context, I mean using the storage of this guy. So all Ethereum balance, all state is going to be kept here, while the code is going to be executed from the logic contract. So in this case, when we have the my wallet contract, what's going to happen is every time you call, for instance, a withdraw function that we have written, it's going to be delegated code that you have written, but it's actually going to withdraw the balance from the proxy contract itself. This makes upgrading very easy because the only thing we do is we just deploy a new contract with a new code, and we just tell the proxy, okay, now just start delegating all calls to the new contract. What this is going to achieve is that all the state here is going to be exactly the same, the address is going to be the same, but the code executed is actually different. Okay, so moving on a little bit more, another of the offerings that we provide with Zeppelin OS is EVM packages. Sorry. Can we make it at the end? Yeah, I'm a bit worried about time since we started a bit late. At the end, we'll be taking questions, as if not, we have a booth downstairs. Just come looking for us and we can talk there. Thanks. So I wanted to talk a bit about EVM packages. So let's go to the same diagram we had a minute ago. Let's say we have an ERC20 contract now instead of a wallet. It's a bit more interesting. If I actually want to deploy my upgradable ERC20 contract, I deploy the code and they create a proxy in front of it. So all my clients are going to interact to call, let's say, transfer on the proxy contract, and it will get delegated to the logic one. But let's say I want to deploy more than one token. Okay, I want to have 2 or 3 different tokens in my system. I don't need to deploy the logic contract that many times because I only need to deploy one proxy for each of them because I want to have one state for each of them. But the code is going to be exactly the same. And actually, all these proxies can belong to different projects altogether. So there can be just a single implementation deployed on the network, and we can have different teams all spinning up their own upgradable ERC20 tokens, relying on the same code. And they can trust this code, because this code is immutable. It's basically a smart contract that has been deployed on the network and cannot be changed. So anyone can create a proxy and point to this contract knowing that that code is not going to change. And something that's even more interesting is that the developer, the guy who actually deployed the ERC20 code on chain, can be even a different team than each of these. So we can have a team that's specialized in writing ERC20 contracts, and other teams that just leverage that by spinning up proxies to that. So what we call this, and of course it's out of the screen, this is actually an EVM package. So the standard of an EVM package is basically a logic contract or a set of logic contracts with related functionality that's deployed on-chain, so other teams can actually use it for spinning up new upgradable instances. So you have one team that develops the EVM package, it deploys it, and everyone else just reuses the code that is already deployed on chain. Upgrades then become very easy. If, let's say, there is a bug fix or an optimization on ERC20, the people behind the EVM package just deploy a new version, and then all the users can just opt in to move onto the new one. They can basically upgrade their proxies and point to the new implementation. Again, all these upgrades are opt-in for the clients. So, sorry. What I wanted to mean is that this EVM package for ERC20 already exists, and it's actually Open Zeppelin. As Fran was mentioning, Open Zeppelin provides implementations of different ERCs, in particular ERC20. So we have Open Zeppelin ETH, which is actually a fork of Open Zeppelin Solidity. And it provides a few contracts that are already pre-deployed on mainnet, Koban, Rinkeby, and Ropsten. So you can new proxies for any of these and start hacking right away without needing to redeploy the code yourselves. These are the actual address where these contracts are deployed on mainnet. So Open Zeppelin ETH also provides initializable versions of all the contracts actually within folders, so they're easy to look for. So providing versions that initializer so that you can use them in an upgradable context. Okay? You should be using, we have 10 minutes. Thank you. You should be using Open Zeppelin ETH instead of the vanilla Open Zeppelin Solidity so that you can use upgrade. How do you actually use EVM packages from your project? It's actually very, very simple. You just have to tell to an EVM package. Behind the hood, this is actually information regarding Open Zeppelin ETH. Right now, we are piggybacking on NPM for distributing that. We plan on having a separate package manager. And once you have linked to Open Zeppelin ETH or whatever package manager it is, you can just instruct Zeppelin OS to create an instance of any contract. So creating an upgradable ERC20 with Zeppelin OS is as simple as linking to the package and creating one, specify the name of your token, initial beneficiary, initial amount, and whatever it is. And Zeppelin OS is going to spin up a new upgradable ERC20 for you. So to wrap up a bit on EVM packages, the already deployed, already on chain, so that your clients can actually, your users, let's say, can save gas calls on that everyone can reuse. So there are like I have deployed the compiler with a different one, and they should be compatible, but they aren't. You know that actually everyone is using the same code behind the scenes. So it really helps when sharing a common standard. It's also very easy for users to upgrade to a new version. It's just a matter of instructing Zeppelin OS to upgrade to a new one, as we saw in a minute before. And basically, that's the idea, to basically be able to ship to your users that's already deployed on-chain, so it doesn't need to go via a whole tool chain, needs to be recompiled, needs to be redeployed, potentially incurring any mistakes or security issues in that process. Creating an EVM package is also straightforward. You also tell Zeppelin OS to start tracking one of your contracts. You push it to a particular network. Push is actually behind the scenes going to upload the logic contract itself. And then you just publish. Since we are working together with NPM still, you also have to publish that as an NPM package. This last step is not going to be needed soon. Also, we have a registry coming up. We are listing here the most notable EVM packages developed. Right now, we have, well, of course, OpenZeppelin ETH, an implementation for TPL. We have a doubly linked list implemented by LivePeer, a TCR, token-created registry builder by the team of Level K. And we have also Gnosis Safe upcoming and packages from Chainlink and Avex. If you have developed your own EVM package, please reach out to us and we'll make sure to get you listed here. So far, it's a manual process. We'll start, as soon as the community grows, we'll start opening it up. So far we have seen OpenZeppelin for developing smart contracts, basically as building blocks for your own contracts, Zeppelin OS for managing them and creating them. And so on to the last product that we wanted to showcase today, we have ZepKit that's actually for managing a whole dApp. I'm going to pass over to Dennison for this.
Go. Yeah, so we're announcing ZepKit. We announced it actually yesterday. We held a workshop around it. And ZepKit is a tool for you to basically jumpstart your development. So it basically includes Zeppelin OS. We have a React app. We have a token for Infura ready to go. We have a number of, we have the OpenZeppelin ETH EVM package already included in there. It's basically a way for you to really supercharge your dApp development. And to support this, oh yeah, here, exactly. It's OpenZeppelin. To support this here at the hackathon, because we're really interested in the community and really wanting to help you guys with what you're doing, is we are having 2 bounties. We're giving away $1,000 for the best EVM package. So you saw before the registry that we have. We're looking to add EVM packages to this, so we're really trying to incentivize you to create cool things on it. The other bounty that we have is $1,000 for the best usage of Zeppelin tools. So that could be something from Zeppelin OS, that could be OpenZeppelin, that could build something on top of the ZepKit itself to make it extensible or more cool. So you can go and join our forum as well if you want to have any questions or reach out to us or start a discussion. We have a lot of people. We're always in the forum as well answering questions. So it's a great place to get support. And we are hiring. We're aggressively hiring. If you are thinking that maybe you'd like to join our team, we're an awesome team. You should come by our booth. We have a form to sign up where you can put in your information and we can get that process started. So thank you.
Yeah, the question was whether we have some sort of semantic version around updates. When you actually publish it, we are basically copying all the information. Sorry, what are all the logic contracts? On chain, we have registry contracts that are automatically generated by Zeppelin. What's going when you link to the new version of the EVM package, you specify which version you want to link to using Semver. Exactly. Any other questions? Oh, hey, how are you doing?
The same variable name, like how does it maintain knowledge of the previous state and upgradable contract?
Got it. You should only be appending new states at the end. You should not be modifying existing variables because it's going to be the previous instantiation. Zeppelin accidentally, let's say, change the type of a variable, it's going to prevent you from deploying to make sure you don't break anything. Any other questions? Benchmarking, gas related, you mean?
Gas related, yeah, just measuring the overall performance of multiple implementations and stuff like that.
It's a good question. Fran, any ideas?
When I have to compare gas, load it on Remix and see two things. When you look at the details for a contract, it shows you like the estimate for each function, but that's not enough because it can vary throughout executions. So execute it and also think it through to know that you're getting the worst case. But I agree, and recently at Open had this idea to build something for that. So if anybody is interested in building it, I think it's a great. Any other questions? Okay.
Great, thank you.